request it from me later on. Okay, so because most likely you won't be able to copy everything down today. I'm going to go relatively fast because there's a whole lot of shit to cover basically. Yeah. All right. Anyone's got any questions with this? Anyone wants to clarify anything? What the hell? Why is that thing there? Whoever pressed the button, the thing away. Okay, guys. Yeah. The next thing I want to talk about is definitely the most important chapter among all of them. Is going to be your speed time graphs and your motion time graphs. All right. For all my students, they know this already. I've said this multiple times. There are only two types of graph they could ask you in the first question. Most likely, it's going to be either a what again? Either a speed time graph or a distance time graph, right? So doesn't matter whatever graph it is, guys. I always tell you guys this, the gradient is supposed to tell you something, right? The gradient must tell you something, because for those who do not know, I mean, I think all my students, they know this already, but for those who do not know, the gradient formula mathematically is change in y over change in x, right? In this scenario here, the y would be equivalent to change in speed over change in time, right? What's change in speed over time again? Very good. In other words, the gradient is supposed to represent the acceleration. Today, if I have a positive gradient, I have positive acceleration, zero gradient, zero acceleration, and naturally, of course, negative gradient means to say negative acceleration. Right? But of course, your exam, they won't give you such easy things. They will most likely not just give you straight line graphs. Instead, they'll give you curves as well. Right? From here, you need to know how to see whether it is an increasing gradient or a decreasing gradient, guys. So let's say I have two graphs here, one of the green one and one of the purple one. Anyone else besides my students, can anyone tell me what the green graph is? Is it increasing gradient or is it decreasing gradient? It is increasing gradient, and thus I know for a fact that the acceleration is increasing here, right? I mean, it should be greener. Then here, obviously, because it's decreasing gradient, the acceleration is decreasing here. Next question that I want to ask, is decreasing acceleration the same as deceleration? No, what does it mean?
There it is.
Yes.
Accelerate at a certain speed, but you're still accelerating when you drop a certain speed.
Very good. Very good. So basically, if you have increasing acceleration numerically, guys, it's 0 meters per second to 10 meters per second to like maybe 30 meters per second to maybe 100 meters per second. Oh shit. This is basically increasing acceleration, right? Whereas decreasing acceleration is like 0 to 10 to maybe 19 to maybe 25 to maybe 26 like that, guys. This, don't waste time, faster sit down and write already. This is what we mean by decreasing acceleration, and this is what we mean by increasing acceleration, guys. It is not the same as deceleration. Everyone, make sure you know this, right? And then what else can you extract out from a speed time graph besides the gradient? Very good. How do I find the distance in the speed time graph? Very good. Area under the graph represents your displacement, guys. Area under the graph represents your displacement. So if you are asked to find the area, if you ask to find this area, you can find the triangle, you can find the rectangle, and then you can find the triangle once again. Right? This one I think most of you guys should know. But bear in mind that tomorrow, is tomorrow or physics? Tomorrow when you go for your exam, when they ask you for a displacement or distance traveled, right, you should straight away look at the area under the graph. Of course, you better take into consideration the time component as well. Let's say, for example, if the question says like from 0 to 10, you don't bloody hell find the whole area, then you deserve to lose your marks, right? So this is important, guys. Make sure you look at the question properly first, tomorrow. Right. Then in the distance time graph, what can you extract? Good. How do I find the speed? Once again, it's the gradient, guys, because once again, it is change in y over change in x, right? Which in this case here will be change in distance over change in time, and we all know that speed is close to distance over time, right? So, these fucking assholes here still playing outside. Okay, so from here, you're supposed to once again see that this is constant gradient, constant speed, zero gradient, zero speed, and negative gradient. Is there such thing as negative speed? What does it mean? Very good. If this was moving forward, this will be moving backwards, guys. Okay, there's no such thing as negative speed, because speed is not a vector quantity. There is no such thing as negative speed. Make sure you remember this. And of course, once again, they'll give you changing gradients as well, right? Let's say, for example, if they have some curve like this and some curve like this, what does this part mean now? In terms of the motion? Good, this is accelerating because you can see that increasing gradient, increasing speed, right? And from here, you can see that it is decreasing gradient, means to say this is obviously, what's this part represent? This part. It's deceleration, guys. It's deceleration. Oh, can you not see? Oh, easy. For those who are sitting a bit far behind, I'll try to write more on top. Okay, so that everyone can see. Okay, so these are the things that you should know for the speed time graphs. And of course, in your exam, I've seen this come up very, very often now. They'll ask you to define it in terms of your forces. So let's say, for example, I have a ball flying from KLCC dropping down all the way. How's the motion of the ball? Will it be like one straight line here, or is it, or what? Or is it going to be like curving like this, or be curving like this? Or is it like some zigzag motion on drugs or steroids or whatever? Right, which one is it? Increasing speed for sure. Sorry, this is a speed time graph, by the way. Will it be 1, 2, 3, or whoever there say 4? 2. It's going to be 2. Why? Why is it going to be 2 here? Eventually, it's going to flatline as well, right? What's this point called again now when it flatlines? Terminal velocity, guys. How is terminal velocity achieved? Good. If the object is falling downwards and is being pulled by gravity only, guys, right? And then upward force will be due to air resistance. Now pay attention, in your exam, they will ask you to mention in terms of forces how this graph works, right? So you're going to say something like this, pay attention, right? You're going to say something like, initially as the speed falls, right? This is due to the fact that gravity is acting on it, right? So as the gravity acts on it, the speed keeps increasing. Then eventually what's going to happen here is that at this point of time, you can see that the graph starts curving downwards. This is due to the fact that air resistance is consistently increasing, right? The air resistance is going to increase all the way until the upward force is equal to your downward force. Upward force is equal to your downward force. And in this scenario, this is where terminal velocity occurs. Okay, so you must be able to explain the dropping motion of the ball in terms of forces, guys. I repeat again, initially there is only gravity acting on it, thus it accelerates, right? As its speed increases, the air resistance increases as well. Thus, it starts decreasing acceleration. The air resistance is going to increase all the way until the upward force is equal to the downward force. That is when terminal velocity is achieved. Okay, ladies and gentlemen, anyone don't understand what I'm talking about? Anyone wants me to repeat it better? Raise up your hand. Yes. Terminal velocity is basically maximum velocity rate. It cannot increase the speed anymore. Terminal velocity occurs when the acceleration is equal to 0 already. Okay. Right. For those who do not know, please write something down. For those who know already, please write something down as well. Don't stare blankly into the screen.
The guy in the is faster.
Your cup noodle just now. It leaked all over the floor.
What?
I already wiped it already. Yep. Whatever. Oh, was it you or was it him?
I didn't buy it.
Okay, whatever.
Immediately.
I think the plastic bag there was a hole. Then after that, when I took the shit up and it started leaking on the ground, but whatever.
It's like it's not.
Nah, it's not. Not really. I'm just trying to blame you. Okay, guys. Okay, I'll move on from here. The next part is basically going to be mass weight density, right? Mass weight density is very straightforward and easy. The only difference you need to know is that what's the main difference between mass and weight, by the way? One is acted upon by gravity, one doesn't care about gravity, right? What's the definition of mass again? What was this? Shit, everyone giving me a blank face. What does this mean? What's the definition of mass? Yeah, it's the amount of matter in the body because you matter, right? You all remember this and all, you bloody fools. Everyone give me a blank space here, a blank face here. Right, it's the amount of matter in your body, guys. The key word is the matter, guys. So it doesn't matter wherever you go, you still have the same amount of matter, right? Right. For example, here on Earth, you have 1 billion matter on your body. You go to Moon, Jupiter, or Mars, your matter will still be the same, right? And thus, because of that, your mass will never ever change. What's the unit for mass again? Yeah. Right. What's the unit for weight? Newtons. Very good. Weight will change, because weight has a formula of W equals to mg, guys. By the way, for those who don't know, a pro tip, W equals to mg is the same as F equals to ma. Most of the time, they are interchangeable, right? The only difference is that weight is always acting downwards, but force could be like literally left, right, up, and down, anywhere. Okay. Most of the time, if you're asked to find the force or weight, right, they purposely interchange these two things, which I see a lot of students, they always struggle. You need to know that they are literally the same thing, right? So yeah, take note. Okay. Then what's the formula for density again? Density equals to OGH. No. Mass over volume, right? And because of this, I know for a fact that it is kg per what? Meter cube, guys. Standard units are all kgs, and velocity volume is supposed to be meters times meters times meters, so it's meters cube. But of course, in your exam, depending on the question, it could be grams per cm cube also. There's no one specific way, right? Make sure you check your units when you do your calculation. I've seen so many of you guys lose marks because of your units. But don't lose marks tomorrow, guys. Make sure you look at the units before you do your calculation. Okay. One more thing I want to mention in terms of density. If you see the word float or sink, you could be damn certain that your question is testing you on density already. The only reason anything floats is because it has less dense. The only reason anything sinks is because it is more dense. Right. So you should be answering your answer according to this formula here, to your best understanding. Right. Make sure you know this. As soon as you see the word float or sink, in your head, you should know that, oh, they're trying to test me on this already. Okay. I mean, simple. Okay, nice. Quite straightforward, easy. This one, nothing much to talk about. Let's talk about Hooke's law. What's Hooke's law again? What's the formula? F equals to kx. What's the units? F is in newtons. Okay. Charles, what's the units for K? Okay, let me ask you. Let me guide you. What's the units for extension? Is it meters? I just told you. Or anything that has to do with length, the standard units are in meters. So what's the units for spring constant? Okay, I just told you. Yeah, very good. Guys, for those who are struggling like him, I've said this, there's a very easy way. God forbids that you memorize the units. No one ever asks you to memorize the units. You know how to get the units, right? You're supposed to make it the subject. Right? You're supposed to make K equals to F over X, and you better know what's the units for force, you better know what's the units for meters, and thus you have newtons per meter. It's the same for specific heat capacity as well, guys. You know, like the formula for specific. Hey, Kashwin, what's the formula for specific capacity again? Very good. Right, Q equals to MC data, right? And if I want to find the units for specific heat capacity, what's the units? What's the units?
Q is
Q over?
Wait, to find C.
Yeah.
We Q over N.
So from here, you know the units for Q, right? What's the units for Q?
Q is
Joules over? What's N verse? How much was the units? What's the units for theta? Yeah, so what's the units? Bloody hell, you tell me you don't know this. I literally just went through this with you last week. What's it? From here, you should know the units, guys. Yes, Justin.
What?
Hey, from here, you should know the units, guys. You are not expected to memorize the units. You are expected to derive it yourself, guys. Make it the subject, and you'll be able to find literally any of the random units already. Okay. Okay, good. Then after that, what else do you need to know? My favorite question among all of them all. The most dreaded topic, moments. Hey, is moments the same as momentum? Sure as hell not. Bloody hell, I'm gonna say yes, I'm gonna come up and beat you right now. What's the formula for moments? What's the difference between moment and work done? Formula for work done is force times distance, right? What's the difference? Okay, both of them could be displacement or distance. Okay. And then what else? Moment definitely has to do with pivots, right? As soon as you see the word pivot, you know for a fact that they're testing you on moments already. But what's the difference? Power. Was it, Jian? I've told you this in class before, right? What's the difference in terms of the direction? One is perpendicular and one is parallel to each other, guys. Remember this, as soon as you see that the force and distance, they're like perpendicular to each other, most of the time they're testing you on moments. And if they're asking you the force and distance the same direction, they're testing you on work done. You should know this, right? Yeah. So let's say, for example, oh wait, before I even move on for an example question, what's the moments in equilibrium state again? Moments in equilibrium. What does it state again? Total. Very good. Total anti-clockwise moment should be equals to your total clockwise moment, right? And from there, we should know that the formula will generally be F1 D1 is equals to F2 D2. Now, pay attention now. When I say this formula is the general formula, right? It's not really the general formula, guys. This is only true if there's two forces acting on the seesaw, right? Or whatever thing the pivot is on now, right? If, let's say, for example, there are three forces, then obviously this formula will not be applicable, right? For example, if let's say I have a seesaw here, right? Kashap is sitting here, Justin is sitting here, and then Ashwin is sitting here. God knows that this seesaw is not in equilibrium now, right? Right, so let's say, for example, Kashap is 50 newtons, Justin is another 50 newtons, and Ashwin obviously is not 50, he's only 40 newtons here. Right. So let's say, for example, guys, let's say, for example, here is 1 meter. Here is another 2 meters. How far should he sit in order for this thing to be in equilibrium? What do we do? Yes, we form the equation first. Very good. So the equation will be once again total anti-clockwise moment is equals to total clockwise moment, right? Then which one is anti-clockwise and which one is clockwise? This one will be anti-clockwise. This one will be clockwise, and this one will be good. Very good. So from here, my equation will be literally F1 D1 is equals to F2 D2 plus F3 D3 here, right? So my formula will be 40 multiplied by, don't know, I'm looking for it, right? Is equals to 50 times 1 plus 50 times 2. Is it? Is it? Is it?
Oh, right.
Guys, let me tell you this. This is literally the best way the students lose marks. They see, oh man, distance, man, distance, man. And they're just gonna bloody follow the number. Right. What's the full name for this distance here? Distance to the pivot. So by right, this should not be 3, this should not be 2. Instead, it should be 3. Right. Make sure you know this tomorrow. Hey, you better look at the question properly. you will lose marks from this because they designed the questions to make you guys lose marks. Alright, so then literally press in your calculator and you'll find the distance already. How much? 5. Okay. Okay, ladies and gentlemen, anyone has any questions? Yes, Charles.
Can you come here? So, and over,
Yes. Okay. Sit back. Catch up. You wanna give up your seat, is it?
Fix your bed.
Until now, we literally got not enough time. I'm not going to be able to cover everything probably today, but I'll try my very best to talk about all the things that I think are relatively important. Okay. Anyways, this is Bowen's. Very straightforward. Please make sure you identify which one is anti-clockwise and which one is clockwise first. That will be much easier to do. Okay, and make sure you don't write the wrong distance. Bloody hell. Okay. Yes. Then the next thing we want to talk about is basically momentum. What's the formula for momentum, Justin? That's impulse.
Sorry.
Momentum.
That's the
Oi, stop panicking. Oi. What's the formula for momentum? What does momentum depend on? Mass and what? Speed. I tell you score anything less than 60, I'm gonna beat you. He's already accepted his fate already. Okay, it's supposed to be mass times velocity, guys. Okay, anyways, let me talk about this up. Guys, for those who have a problem memorizing the momentum formula, just ask yourself, right? If today, yet again, with no any way of discrimination, a fat kid were to run against a skinny kid here, right, at the exact same speeds, right? Hey, no discrimination. Don't laugh first, right? Who's gonna have the bigger momentum? This guy is obviously gonna have the greater momentum, right? Because the mass is and velocity are involved, here, right? Okay, if you must, you can remember this very little, beautifully drawn story I've just told. Okay, easy way. Okay, then after that, impulse is a very commonly asked question, guys. Impulse has two formulas. What are the two formulas again? Ft equals to mv minus mu. For those who forget how to use, for those who cannot remember the impulse formula, guys, what's the way we derive the impulse formula again? Very good. It's supposed to use F equals to ma, guys. From here, you're supposed to know that acceleration is essentially v minus u over t, right? Expanding the bracket, you'll get mv minus mu over t, which will ultimately give you ft equals to mv minus mu. Of course, if your algebra is absolutely dog shit, man, you're gonna have a problem with this one. Alright. Hopefully, I think Wesley students, they don't have a problem with their mathematics. Huh? Set 3 and math. What's set 3? Don't have to memorize this. Once again, you can get it from this here, your F equals to MA formula. Right, in the case that you forget right? Okay. And what else do you need to know? Okay, talk about principle of conservation of momentum. Wait, shut up, wait, Charles. Hey, Charles, shut up, wait.
Yeah, no.
What's principle of conservation of momentum again? Guys.
M1 V1 plus M2 V2 equals to M1 V1 minus plus M6.
I must say, good attempt, but I lost you halfway there already. It's M1U1 plus M2 U2 is equals to plus M2 V2. Among these formula here, the most commonly asked in your exam is going to be inelastic collision, guys. How does inelastic collision look like again? I have ball A knocking into ball B, and then after that, what happens?
It's a little bit.
Shut up, lah! Everything is about. What happens after inelastic collision when ball A knocks into ball B? They stick together very good. So after they stick together, what's going to happen is it will look something like this, lah, right? But move at the same time. Yes, I know you guys have raging hormones, but please. Just two balls here, all right? Okay, so a very common example will be that is, everyone, I want you to do your calculation. Assuming the mass of A was 5 kg, the speed was moving at 6 meters per second, and the mass of B is 7 kg. Find me what's the speed here. How do I do it? Okay, sorry, maybe, oh wait, I gave you the formula already, right? Yeah. Everyone, I'll give you 2 minutes to solve this. Tell me what's the answer.
Oh my God. Oh my God.
What do you want me to answer? You mean you don't know what inelastic collision is? How much? No, wrong. Let me explain it. How much? Very good, Chi Zheng. That is correct. Yes, I believe you. Okay, guys, the answer is supposed to be 2.5. Why? What are you supposed to do? For those who do not know, guys, you're supposed to literally substitute everything into a formula. This is before collision, right? So this part belongs here, right? And this is after collision, right? Which means to say this part belongs here because principle of conservation of momentum states that the total momentum before collision is equals to the total momentum after collision, guys. Right? So literally this part belongs here and this part belongs here. So literally substitute your formulas in, right? So from here you have something like 5 multiplied by 6 plus 7 multiplied by 0 is equals to, the mass is still the same, V1 plus 7 multiplied by V2 here. But here is the problem, guys, which a lot of you guys always have a problem. This is only one equation, right? How can there be two unknowns? Yes, the velocity are the same because, as I mentioned, they are already sticking together, right? And if they are sticking together, then there could no longer be V1 nor V2. They should only be a common V. So it's literally 30 is equals to 12V. Right? And from there, your V would be 2.5 meters per second. This thing is supposed to be traveling at 2.5 meters per second. Yes, boys and girls, this is the most common one in terms of your principle of conservation of momentum. You must know how to do this calculation. It's substituting one by one in only. Do you understand or not?
Oh my God.
Shit, there's too many people here. It's getting a bit tired. Okay, guys, anyone have any questions with this? Yes, guys. Today this room is very hot because Kashap is here.
What? I'm 16. I don't do this. I don't want to.
They did a trauma already.
Excellent emitter of heat.
Huh?
Excellent emitter of heat.
Shit, man, it's rude. It's important. Alright. So yeah, what else do you need after this? Basically, the next one is going to be energy already, alright. In terms of your energy, explosive collision. Okay, I'll give you an example right now. My most favorite, one of them in terms of the principle of conservation of momentum, but rarely comes out, is the explosive collision. Let's imagine this is a gun. This is a very beautifully illustrated gun. And inside this gun, there's only one bullet in the chamber. Okay? Okay, but anyways, so let's imagine today, if we apply the principle of conservation of momentum, right? Same thing now, right? M1U1 plus M2U2 is equals to M1B1 plus M2B2 here. Right, the same thing. But from here, I know for a fact that straight away here should be 0 already. Because initially the gun and the bullet is not moving now. Right? But after the gun fires the bullet out, and suddenly becomes fat also. Right? The bullet and the gun is going to recoil a bit, right? If you ever see all the action movies, you see the gun always recoil on, right? So let's imagine the bullet is, let's say, for ease of calculation, 1 kg. No damn bullet is ever 1 kg, and the gun is, let's say, 10 kg. No damn gun is going to be 10 kg, right? But for ease of calculation, let's assume that the speed the bullet is moving at is going to be 300 meters per second,
Wow.
right? Almost the speed of sound, right? How do we find this here? The velocity of the gun after you pull the trigger. Yeah, literally just substitute the formulas in once again. All right, so this formula is important because once you have this, it's just doing only 10 multiplied by V1 plus 1 multiplied by 300, right? From here, if you press this in your calculator, you'll get like negative 10 V1 is equals to 300, and naturally your V1 will be moving at a ridiculously fast speed of 30 meters per second. Because initially both of them are not moving. So anything multiplied by the speed of 0 will be 0. Yeah. Good, very good question. Why is it negative? Why is it negative here? What does it mean? It's moving at the backwards direction, guys. It's moving in the backwards direction. That's why you can get a negative. Guys, I want to emphasize this also, guys. In terms of your momentum, when you do your calculation, you have to take into consideration the direction it's moving in. Because depending on the direction it is moving in, it may be positive or negative. And most of the time in your questions, they will not mention that it is negative velocity or positive velocity. They will mention that it is moving forward or backwards, upwards or downwards, right? If you associate upwards as positive, your downwards must be negative. If you associate left as positive, then your right must be negative. But it doesn't matter which one you associate with, as long as you know that the opposite direction is a negative number, is a negative value, then can already. Okay, so take note on this tomorrow as well. Okay, anyone has any questions? Good, 100% absorption rate. That's what I like.
Yeah.
I got a little chuckle there. Basically the principle of conservation of energy, guys. In terms of your principle of conservation of energy, what does it mean again? What does principle of conservation of energy mean, sir? Good, very good answer. Energy can never be created nor destroyed. It will always be transferred from one form to another. In your IGCSEs, the most famous transference of your energy is always going to be either potential energy to kinetic energy or vice versa. Okay? Along this here, what's the formula for potential energy again? Very good. MGH equals to? Very good. Half mv squared here, right? Now, let me tell you a simple question that they always like to do. They say that, okay, right now I have a ball falling down at a height of, let's say, 100 meters. Find the velocity here. No other information. No mass, no nothing. Can solve for this kind of question? Can you solve it?
Yeah.
Yes, very good. Why?
Because you don't need to mix something about.
Good. You pay attention, guys. You don't need the mass component here because once you bring it over, they'll cancel each other out, right? You know, like mathematically, you don't need your mass. So if you see your question, they say something like, oh, there is a height and then the ball is falling with a certain distance. They ask you to find velocity, right? It's literally going to be GH equals to half V squared. And from here, you just do your algebra only. Okay, you only need to do your algebra only. I mean, you can press in your calculator and find out how much this is now, then see if you're understanding it correct. Hey, find me how much is velocity, real quick.
4.2.
Do anyone couldn't get 44.2?
I still can't understand.
Okay, so I know for a fact that from here the potential energy is 100%, right? Right. And then as it loses all its height, the potential energy here is 0%, right? Right. So the energy must be converted somewhere, am I right? And in this scenario, it will be converted into kinetic energy, right? Right. So that's why I assume that all the potential energy is fully converted into kinetic energy here. From here, if they give me just one value itself, one height value itself, I can already find how fast it is falling downwards already. Right? Like how fast this speed is going here already. Okay? Can you see it?
Yeah.
Why? Because I relate this formula, mgh equals to half mv square, right? If I do mgh equals to half mv square, I can cut this mass away, right? Because they're the same component. It's like 3 times 2 times 5 is equals to, I don't know, like 3 times 4 times 2.5 lah. Right? These two will cut each other off, because they're the same thing.
Yeah.
Right? So from here, I don't need the mass component. With the height component itself, I can find the velocity already. You get what I mean? Because it's just algebra GH, which is supposed to be mgh, right? I cut the m away, and I cut the m here also, equals to half mv square, but I remove the m already. You get what I mean? So this is how I end up with the transference of energy. Now, it's not only limited to potential energy to kinetic energy. It could be kinetic energy to potential energy as well. Let's say, for example, this ball is being shot up, right, with a speed of 10 meters per second. How high will it go? It will be the same question also, right? Just in reverse only. In this case here, it will be half mv square equals to mgh, right? Which in this case, once again, you don't need the mass component. Then from here, you should be able to find the h. Hey, can you guys press in the calculator and tell me how much will the h do? Huh? 5.1 meters. Did everyone get it? Anyone couldn't get 5.1? Okay, excellent. So be careful tomorrow when you guys. Oh, there's one condition for this. There's one keyword that I see principle of conservation of energy happens the most. Is when there is no air resistance. If you see the word there is no air resistance, straight away you can assume that the energy is fully 100% converted. And if they ask that in reality this is not possible, right? In reality, maybe the speed is only 40 meters per second only here. Why? Why? What happened to the energy? Yes, very good. The most common answer that you can answer for tomorrow, energy is lost to the surrounding as heat and sound. I repeat, the question will be something like, in reality, we know for a fact that the speed won't be that fast. Maybe it's only 40 meters per second. Why? Explain in terms of the energy. Where did it go? In reality, I can't 100% convert it into kinetic energy, right? Maybe somewhere along the line, 10% of it was lost to heat. Maybe somewhere along the line, 10% of it was lost to sound, right? So this is where the energy is lost to. So it can't fully convert into kinetic energy, and thus your speed is decreased. Same thing for this one also. In a perfect world scenario, it will reach 5.1 meters, right? But in reality, maybe it can only reach 4.5 meters only, because once again, the energy is lost to the surrounding as heat and sound. Okay, very straightforward, very easy. I hope everyone knows how to do this, especially tomorrow. Please tell me the good news. Okay. Anyone has any questions with this part here? Energy. Oh, by the way, in your exam, I know your school. I've told this to my students. I know your school teaches you that power is equals to work done over time. This is only half true only, guys. What is it really? Power is supposed to be equals to what? Energy over time. The energy is all interchangeable. It could be work done, it could be potential energy, it could be kinetic energy, it could also be heat energy, guys. Depending on what the information is given to you on the question itself, you are supposed to derive the formula into here, guys. So don't fixate your mind only to work done. right? If not, you keep looking for the force times distance. Like they give you the MC data already, you're still looking for force times distance. Then it's GG. Okay, understand? What's the formula for efficiency again, by the way?
Useful energy.
Output over input or input over output?
Input.
It's output over input multiplied by 100%. Right. And if you find your efficiency more than 100%, you are very good. You can never have 100% efficiency, even though your mother told you that you're perfect, right? But in reality, there is no 100%. Unfortunately. Heat energy bro, MC data. Okay. Yeah, everybody. Okay, then after that, moving on. The final formulas are basically pressure only, right? What's the two pressure formulas again? F over area, right? And also rho GH, right? Everyone knows this, density, gravity, height, force, and area. Right? I mean, this one is very easy, straightforward. Okay, one thing you just have to be careful of is, if let's say, for example, they say that this is the point of interest. Is this my H for water? Is it? No, it should be this one. It should be the water coulomb above. Okay, be careful tomorrow if they ask. Like literally, this is the only way you can lose marks in terms of the calculation. If not, I think you guys should be fine. Okay.
What?
Sorry?
What's rho?
What the hell? Rho is density rho. Mass over volume. Then G is gravity. It's 9.8 by the way. But if you see any past year papers, it's all going to be 10 because of the change in syllabus last year only. Yeah. Yeah, force over area. What's the units for pressure again? Pascals. If you cannot remember Pascals, even if you write Newton per meter square is correct also, because PA is a derived unit from Newton per meter square. PA bro, pressure Pascals. Zero. Okay, guys. Yeah, without wasting any more time, let's talk about the heat chapter, guys. In terms of the heat chapter, they'll ask you very basic stuff They'll ask you like the first thing is like the solid, liquid, and gases. You better know how's the arrangement, how's their density and molecular movement. The solid particles move how's the motion of solid particles Very good. Solid particles vibrate at fixed positions Then liquid and gas obviously free to move about in the container Right. Then after that, how do you change degrees Celsius into Kelvin again? 27. Yeah, just 273 is good enough. 273. So let's say for example 0 degrees Celsius is plus 273 to become 273 Kelvin, right? 100 degrees Celsius is obviously the same thing, which is 373 Kelvin. And 0 Kelvin will be what, guys? What's this value again? Absolute zero, guys. Absolute zero. Absolute zero. Do the particles still vibrate? No, this is absolutely zero energy at this point. Right. So the particles don't even vibrate anymore. But this is also introduced this year only. So maybe or maybe not. Come on, guys. Absolute zero, bro.
Oh.
Yes. Negative Kelvin. Oh, negative degree Celsius depend. So let's say for example, negative 100 degrees Celsius will be 173 Kelvin. Right. So theoretically, you can only go until negative 273 degrees Celsius, which is going to be 0 Kelvin already. Okay. Very good question. Please clarify the points. And for those who do not remember this 273, you can remember that this is actually Mariah Carey's birthday, 27th of March, which is absolutely unrelated. I didn't know about this. Also, one of my students told me, "Oh shit, how am I gonna remember this 273?" And she was literally just typing 27th of March. Oh, Mariah Carey's birthday. Happy birthday to you. Okay, so whatever way lah, whatever dumb way you want to remember it lah. Doesn't matter as long as it's something dumb, then you can remember it already. Instead of just the number, right? No one remembers the number. Okay. Then in terms of your pressure, guys, how does a pressure in the container work again today? If let's say I say that I want to know in terms of the air molecules, right? How does it exert a pressure on the container? What's the keyword again? Collision what? With the other particles or the wall? It's the walls, guys. It's the collision against the walls of the container, guys. It's always the collision against the walls of the container. Unlike what you learn in chemistry, the particles must collide with each other, right? Physics don't care about this at all. Okay, we want, in order for the pressure here to increase, you think about pressure, right? Pressure is going to be force over area, right? If they ask you in your exam, guys, pay attention, you need to write something like this down. You're supposed to say that as the air molecules collide against the walls of the container here, right? This increases the force per unit area, ultimately increasing the pressure. Okay, I repeat again. As the air, you won't be able to write everything down. Just think about the keywords, okay? As the air molecules collide against the walls of the container, this increases the force per unit area of the container, ultimately increasing the pressure. Right, so the pressure could be affected in one of two ways only, right? Either it is affected by good temperature. When the temperature increases, what happens to the pressure? Good. Why? Good. The particles have more energy, move faster, and thus have a greater rate of collision against the walls of the container, right? So obviously the pressure will increase. And the second way to increase the pressure is by decreasing the volume. Very good. Because when you decrease the volume, what happens is the air molecules will have less space to move around, and they will obviously collide against the walls more frequently, guys. So you need to know these things. Okay? So you think about it, I mean, you have to have the picture in your head. Why does the pressure increase? It all boils down to the collision against the walls, depending on what the information wants from you, what the question wants from you. Okay, Justin. Gonna be information overload very soon already. Trying to cram in so much shit in there. Okay, guys. Yeah? Anyone has any questions about this? And there's one more thing that you need to know. The pressure volume formula. What's the formula again? Boils law. Yeah, this is the only formula for this part here. For this part here. Oh, and Brownian motion also, guys. What's the two keywords for Brownian motion? Random speeds and zigzag motion, guys.
So speed
Boils law. Yeah. Okay, ladies and gentlemen. Sorry, what? Oh. Okay, then after that, the next part would be the heat expand and cold contracting that everyone knows. Then it's going to be specific heat capacity, which I've already talked about, guys. Specific capacity is Q equals to MC theta, right? Sometimes they may change this into power as well, guys. If they change it into power, it's supposed to be power times time equals to MC theta. Depending on the situation, you should be able to solve either one. Okay, please read the information properly and use the proper formulas when you do your calculation. Hey, when I have very high specific... Oh, by the way, one more thing I want to talk about. How do we define specific heat capacity again? What's the definition for specific heat capacity?
If you change the temperature of 1 degree of an object by 1 degree Celsius.
Good, very good. First and foremost, you're supposed to remember the formula. Hey, pay attention now. You're supposed to remember the formula and you're literally gonna bullshit your way through. Pay attention now. Specific heat capacity is the amount of energy needed to change 1 kg of a substance by 1 degree Celsius. Easy? Easy. I repeat again. Specific capacity is the amount of energy needed to change 1 kg of a substance by 1 degree Celsius. Literally just bullshit your way through the whole formula and you'll get it ready. Because P power times time is equals to energy. Yes. Dude, literally just say the power equals to energy over time, right? And the energy could be anything, right? Okay.
So ignore him.
Okay, guys.
I want to get a lobotomy.
What else was important from this chapter? Oh, conduction, convection, and radiation. More or less, you need to know how to define it. How does conduction occur again? Hey, in terms of the particles movement, how does conduction occur again?
Vibration has energy to each other.
Good. So basically, the keyword here is if they are heated, they will vibrate and pass energy to the adjacent molecules, right? There's one more thing you should be careful of. If let's say this thing is a metal, what is one more keyword that you must mention? Good, it is the free moving electrons, guys. If it is a metal, you must mention the keyword that there is free moving electrons passing on energy from the hotter region to the colder region. But if this thing is a plastic, you bloody better not write free moving electrons, right? So be careful. Only if it is a metal, then you can write the free moving electrons. If not, you just mention the particles gain energy and vibrate and pass on energy to the adjacent molecule. So the hot end, it passes energy from the hot end to the cold end. Everybody. Okay. Then, what about convection? What's the key thing you must talk about convection, guys? Heat always what? Heat rises, right? Right. So if you talk about convection, usually most likely they're going to ask you in terms of the density of the liquid, right? So let's say, for example, this is your Maggi Mee pot that you're cooking, right? Not the cup noodles. So let's say, for example, I have a heat heater here. We just focus on 2 particles. One particle that is closer to the heat source, and one more particle that's relatively further away. If they ask you to explain in terms of density how convection occurs, what's the first thing you want to talk about? Good. Why will it become less dense? Good. Heat expands and cold contracts. So this one here is actually going to expand, right? According to your density formula, which is mass over volume, when I have an increase in volume, I'll have a decrease in density here, right? And thus, what's going to happen is the heat will rise to the top longer, right? Then obviously, it's not going to leave an empty space here, right? It's not going to produce a vacuum, right? So the cold air goes downwards. So the colder molecule goes downwards, and the whole process repeats itself, guys, right? We're supposed to mention that the hot particles expand, decrease in volume, decrease in density, and rises to the top, displacing the colder particles downwards. Yes. And this is also the reason why there is wind, guys. Wind energy comes from the sun, right? Because of the heating and cooling of the air also. That's why you can feel the circulation of air going up and down, up and down. It's the same scenario, guys. For those who do not know, right? Let's say, for example, this is the sun, right? And then it heats up the tar road here. This thing is going to cause the hot air particles to rise towards the top, displacing the relatively colder air downwards. And this is how wind occurs, for those who do not know. Okay. Shit, I only have 30 minutes left. Gotta cut a lot of shit down, right? What else is important? In terms of the radiation part, if they want to test you on radiation, radiation is the only heat source that can travel in. Very good. Right, radiation is the only heat source that can travel in vacuum. If they want to test you on radiation, right, for sure they'll write these words on. They'll either write black, white, or silver. Once again, with no racism intended. Stop looking.
You had no reason to do that.
He was looking already, this guy. Shut up, lah. Okay, if you see the word black, white, or silver, they are definitely going to test you on radiation already. You should know that black is the best. What did you say? Oh my god, man. What did you just say?
I said,
Black is the best.
I said, I'm right.
Best what? Absorber and emitter of heat, guys. Right, black is the best absorber and emitter of heat. That's why it's the hottest and it will radiate heat the most. Then obviously silver is the best reflector of heat. If you see this black, white, or silver, you must mention these three words, guys. Absorb, emit, or reflect, guys. It's all going to be revolving around these answers. Huh? Oh, in between. Yeah, so it's like this. Because silver is the best reflector, right? If you think about it, the cars that park right, they always have this windscreen thing. The silver is supposed to reflect the heat. Yeah.
That's racist. Should say that.
Realization. Okay.
Don't say that in the Chinese.
Yes. What? Yes.
Don't say that.
Sorry? Very good question. This is a little bit out of your scope. Like for example, the reason why you can see here as a red color, right, is because you know white light comes in at 7 different wavelengths, right? And then this part here basically, like not this part because it's projected, right? Like let's say for example this one here. You can see that this is green in color. It's because the white light that comes in here, everything is absorbed already, except for the green color light. So the green color light reflects back into your eye, and you can see green in color, right? Black is the exact opposite of that. Black is the exact opposite of that. The reason why you see black in color is because all the 7 colors that enter the thing, right? All 7 of it is absorbed already. Meaning to say very little light is being reflected back. So it's black in color. Okay. But this is beyond your scope, but it's good to know. Okay. Anytime you see, oh, this is black color because it absorbed all the 7 colors. This is red color is because it absorbed all the colors except for red. This is green because it absorbed all the colors except for green, and so on and so on and so on and so on. Huh? Emit is basically emit like 散发出来, you know. Some is like emitting out the heat, you know. I'm like I have to absorb the heat, then I have to emit the heat upwards, right? Yeah, it's the same as radiation.
The money coming.
What?
Oh,
Wow.
oh my God,
Okay. Oh shit. Anyways, one more thing I want to mention, guys. If you ever see the word, shut up, listen. If you ever see the word infrared, guys, I want you to know that infrared is responsible for anything that is hot, i.e. ketchup. Oh. What? Okay, anything that is hot, anything that is hot is because there is infrared radiation in it, right? You feel when you put your hand under the sun and it's damn bright and then it feels hot, right? A lot of people think that, oh, because it's damn bright, that's why it's damn hot. It's damn bright is because you see a lot of visible light, but it's damn hot is because the infrared is emitting. And if you place your hand under the sun for 12 hours straight for 10 days, you will get skin cancer because on top of the infrared and visible light, there's also UV ray shining down on you. So the Americans are going to die once again. I mean,
okay, so you know how when a fat person sits on the chair and they get out of the chair really well? Second,
yeah, for sure. Hey, what the hell? Don't do that. Yes. Yes. Not as dramatic, yes, but yes, the theory is this. Okay. Okay, yeah, anyways, moving on to the wave chapter finally, in the last 30 minutes, right on time. Okay, talking about the wave chapter, there's actually a lot of things you need to know, guys. First and foremost, in terms of the wave chapter, you need to know what's the difference between a transverse wave and a longitudinal wave, and you need to know how to define it. Is this a transverse or a longitudinal wave? This is a transverse, right? And a longitudinal wave looks something like this, right? Something like this, longitudinal wave. Let's talk about the definition first. How do we define a transverse wave again? Okay. The vibration, right, is perpendicular to the direction of wave travel. The vibration is perpendicular to the direction of wave travel, otherwise known as propagation. But most likely, a lot of you guys don't remember the word propagation. The direction of wave travel. Yeah, if your English very high tech, then you can write propagation, right? If you are yeah, that's the definition. And anything that has vibration parallel to its propagation is a transverse wave, and longitudinal wave will be the exact opposite. The vibration is parallel to its propagation, right, or direction of wave travel. Okay, this is the very definition. Propagation. Vibration parallel to its propagation. Longitudinal waves has vibration parallel to its propagation. So just remember, one is parallel and one is perpendicular, guys. Very simple definition. Now after that, you need to name I think you all know how to name the waves, right? Right. For example, if this is the equilibrium, this thing is known as the crest or peak, right? This one is known as the trough or trough, however you pronounce it. And then here to here is known as the bloody hell, that is wrong. Here to here is the amplitude. Crest or peak. Guys, I tell you what, I see some students, they tell me that this is the amplitude. I will beat you. You know it already. You know it already. This is your amplitude, right? And then wavelength, wavelength, is it from here to here? Is it considered one wavelength? It is from yeah, either here to here, or here to here, or here to here, guys. Right. Right. Yeah, very good. As soon as it starts repeating itself, it's considered one wavelength. Crest to crest, or trough to trough, or trough to trough, or equilibrium position to equilibrium position. Right. As soon as it starts repeating itself. It's equilibrium position now, this one. I just said that this here is one wavelength. Wavelength of equilibrium position, literally your x-axis, bro. Okay, oh, this one here, what's this hardball? This is ref action, guys. Wavelength is wavelength here to here. Is it one wavelength? No, it should be as soon as it starts repeating itself. Also, it's here to here is considered one wavelength. Yeah. So what? Compression. Yeah, compression and refraction. Compression has a definition also, guys. Compression is the pressure, a region of high pressure, thus the molecules are close together. Whereas refraction, the pressure is lower, thus the molecules are further apart. Yeah, rare faction.
Oh my god.
Okay.
So. They all have something. Yeah, but this one works. I'm looking for one goes. It's still funny.
Peak is the top of the wave. Peak to the peak.
That's in Japanese, sorry.
Okay, moving on. What's the formula for speed of wave again? Good. V equals to F lambda, guys. Right. I hope everyone knows this. Then in terms of the phenomena of the wave, guys, there could be like three, right? Reflection, refraction, or diffraction, right? I think reflection everyone knows, so I don't want to waste too much time because I don't have time. So let's talk about refraction. Okay. In terms of a refraction of wave, what's going to happen is they'll usually give you something like this. They'll say that, okay, right now this is a deep region and this is a shallow region. First and foremost, I want to ask, which one is traveling faster? The deep region, the speed is faster, guys. The shallow region, the speed is much slower. If let's say I have wave fronts coming in here, like this, right? Will the wave lag behind or lead forward? It will lag behind now. So this was the original wave, right? It starts lagging behind and looks something like this. Once you have two lines that are parallel already, all you need to do is just draw parallel lines all the way only. And make sure that the wavelength is the same after diffraction. After refraction. Right. You all need to know this, by the way. Right. And it will be the exact opposite for shallow to deep. Right. So let's say this is shallow and this is deep, right? If the waves are coming in like this, right, what happens is the speed actually increases, right? The speed here is slower, the speed here is higher, right? So what happens is the wave is going to lead forward this time, and it leads forwards this time. It looks something like this, right? Without you adjusting automatically, the wavelength is going to increase already, guys. So you need to know this also. It's either going to lead forward or lag behind only the waves, depending on whether it's faster or it's going to go slower. Okay. And of course, the next one is going to be the diffraction of wave, guys. Hey, what's the condition for diffraction to occur more or less again?
Yeah.
Is the gap, how should the gap be? Good. Guys, pay attention. For diffraction to occur more, guys, the wavelength must be larger than the gap. As long as the wavelength is large, your diffraction is going to occur more, okay? And when you're asked to draw for diffraction, guys, as long as your wavelength here is larger than your gap here, right, there's going to be a very nice Wi-Fi signal, right? But in a scenario where your gap is larger than your wavelength, right, then obviously what's going to happen is your Wi-Fi signal will become retarded, right? It will look something like this. What?
Don't say that about my president. My president.
Okay. These are the only two scenarios, right? Either more diffraction or less diffraction. Nice Wi-Fi or not so nice Wi-Fi.
Are you saying retarded people are not nice?
I don't know.
You're on the spectrum.
Okay. The gap cows.
Find this video.
Hey, by the way, guys, tomorrow when you draw this, you should know that after diffraction, the wavelength still is the same, and you should start at the gap here. You don't like start somewhere here. It will be wrong, by the way.
Yes. 3 lines.
Not necessarily. You have to see what the question wants. But in general, you must draw at least 3, unless stated otherwise. You need to draw at least 3 diffracted waves in general. Okay, boys and girls. Taller than the gap, what do you mean? No lah, this like this scenario. What do you mean? Like this? It doesn't matter, bro. It's wavefronts only.
Yeah.
It doesn't matter. Okay, understand? Then after that, I'll talk about is basically the light waves. Okay. For light waves, they could ask you to draw two things only. Either the reflection of the image or the refraction of the image. Okay. If they ask you to draw the reflection of the image, let's say for example, this is a mirror. Don't ask me this again. This is a mirror. So let's say for example, I have a light bulb here, right? And I'm asked to draw the reflection of the light bulb with two light rays. The proper way to do it is something like this. You're supposed to draw one light ray here, measure the angle here, measure this angle here, draw one more here, measure the angle here, measure the angle here, draw, and then you're supposed to dot, wherever the lines cross, this is where the image is. Okay. Now this is the proper way to do it. Okay, but there's a much better way to cheat. Okay, so what you do is, right, you think about it very logically. Whenever you stand in front of the mirror, what's going to happen is the image in the mirror will be literally exact distance away from the mirror than you, right? So let's say, for example, if this is 5 cm, right, your image should by definition be 5 cm into the mirror also, right? Right, then you know that this should be your image already, right? With this, much easier. Literally, like you can cheat already from here. Of course, you bloody erase all the things that show that you were cheating, right? Then after that, you're going to do something like dot, then straight line already, then straight line already. And straight away, just like you pretend like you measured it, right? You measure this, you measure this, you measure this, and this. For sure, correct one. If you do it this way, 100%. But if you do it the proper way, right, what's going to happen is, right, if here the angle is a bit off, or here the angle is a bit off, right, your image, I've seen students dare to draw me this, the image is here. Wow, I tell you, you're in a fun house, man. This is not a proper mirror. You're in a fun house, guys. Okay, make sure you cheat, You always have to cheat.
Make sure you cheat. Make sure you cheat.
Yeah, as advised by my tuition teacher. Okay, very straightforward, very easy. Then for refraction of waves, refraction of light is the same thing also. So most likely they'll give you something dumb lah. They'll say that, oh, okay, right now I have something here, and I have an eye here, and then like water here, and then I say that, okay, there's an object here. Find me the refracted image with two light rays. The proper way is to do something like this. Okay, you're supposed to draw the light rays out here, right? Bend it here. And then you're supposed to dot. This is where the image was supposed to be. Okay, but this is very hard for the students also, I noticed. So once again, there is a way to cheat. And the best way to cheat is to understand that if they ask to draw refraction, right, your image for sure will be slightly above and towards the left or right of the object. Okay, so if you have this already, once again, what you do is you straight away draw the image first. Okay, so if you draw the image first, for sure your light rays will be damn nice one. You draw the image somewhere here, and then literally because you know it's supposed to converge, right? You draw a straight line, and then you converge it here, then you just refract and refract. And Gaudium already, much easier, much straightforward. Okay, you must have this image in your head, If you have this image in your head, it will be much easier to cheat. But if you don't have this image in your head, then good luck, do the normal way. Okay, ladies and gentlemen, this is very important. They will ask you to draw this one. Okay, last thing I want to talk about before we end the day. Should I talk about the refractive index, or should I talk about lens one?
Draw the endoscope.
Okay, guys. Okay, in terms of endoscope, guys, you know endoscope is an application of what? Good total internal reflection, right? And because we know the endoscope is an application of total internal reflection, we know for a fact that total internal reflection can only occur beyond the critical angle. Okay, for total internal reflection to occur, the angle must be greater than the critical angle, right? So let's say, for example, if I have a glass prism here, by right, if I have light rays going in like this, it's supposed to refract, right? Then if I have light ray going at the critical angle, if let's say this is the critical angle, it will go through maximum refraction, guys. And of course, beyond the critical angle, it's going to be total internal reflection already, right? Right, everyone knows this, right? Now, first and foremost, total internal reflection can only occur from higher dense medium to lower dense medium. For example, if today you go into a swimming pool and you look up to the surface of the water, everyone here knows how to swim, right? Right. Anyone here don't know how to swim, go learn how to swim. It's very important. So you dive under the swimming pool and you look to the surface of the water, you'll notice that you can see the tiles on the swimming pool, right? Because total internal reflection is occurring already, right? That happens is because it's from more dense, which is the water, to the less dense, which is the air, right? But if today you take a piss on the ground and you see your own reflection in the piss, right? That is not total internal reflection, guys. That is just normal reflection. Okay, remember this, right? And then in terms of your total internal reflection, there will only be two applications only. Number one, it will either be optic fiber. What's optic fibers for again? Optic fiber is literally your internet cables, guys, not your Wi-Fi. And if you ask about optic fibers, if they ask you to draw, don't draw something like this. You will be wrong. Okay. Ideally, you want to have maximum 2 bounces only, right? Because the law of reflection still occurs here, right? You can't, your incident angle must be still the same as your reflected angle, right? So pay attention, you can only have maximum of 2 bounce. This is optic fiber in telecommunication. And the second one, which is very commonly asked, is basically your optic fibers in terms of medicine usage. If you talk about medicine usage, it's for sure going to be the endoscope already, right? Everyone knows what the endoscope is, right? The one where you... Oh, by the way, for those who do not know, endoscope is something that shut down your throat to view your internal organs, right? But in terms of people that usually have like some really bad form of acidic gastric, they will need to use an endoscope to be shut down by the doctor, right? And then they see where's the scar or tissue or ulcer is in your stomach, and then they'll operate there, right? But some people, they have really huge gag reflexes, you know, like so bad that they can't even swallow pills, right? You guys have a friend that cannot even swallow pills, right? Let me tell you, if let's say your health is no good, right? Your health is no good, and then you need an endoscope to go into your stomach, right? If it ain't going through the front, it's going through the back. So take care of your health, boys and girls. If you don't want to be literally, you don't want to be violated backwards, then take care of your health. So anyways, for those who look at the questions, guys, if they ever ask you to draw an endoscope and application and everything, right? This is one of my favorite drawings, which all my students know by now. It's basically the human Pac-Man. Okay, the human Pac-Man looks something like this. You literally draw a Pac-Man. Right. Then you draw a CD for him. Shoots electronic device. Cannot draw already, shit. They don't allow me to draw. Okay, you draw this. Then after that, guys, you gotta label everything at the end of the day, by the way, right? This is your monitor for the endoscope, right? Then this is your optic fiber for total internal reflection, and this is your camera, guys. Okay, if they ask you to draw, I know there's a very complex drawing somewhere online. I've seen it before as well. Don't draw that. Just draw this Pac-Man, much easier. Make sure you label everything. However ugly your drawing is, right? As long as you label it, most of the time you'll be okay, okay. So this is that. And if they ask you for what's the application of endoscope, you just say it's to view internal organs.
65. I didn't think about it. I'm feeling that actually.
Oh my god.
No.
Okay, go for it. Okay. Guys, that's gonna be it. Guys, one more last thing we can talk about before we end the day. Okay, I think this is important. Okay, last thing we're gonna talk about before we end the day. Okay, it's gonna be the refractive index. What are the 3 refractive index formulas again? Good. Then COB then. Very good. Excellent. Right. Now, one thing I want to highlight is basically going to be this one here, right? Which most students will always lose marks in this calculation. My students in class, they already know about this, but for the benefit of everyone else, please pay attention. You know, like for example, let's say the question looks something like this, right? They say that, okay, this is the glass, and this is the air, right? And then let's say, for example, they even say, this is the incident ray, and they say that this is 30 degrees. And they give you the refractive index here is 1.5. Find me this angle here, everyone. Everyone find me this angle here.
$48.6.
Oh.
Very good. You better know this. How much? Do you do your calculation?
All this.
How do you do the calculation?
5.7 would be equal to 9,500.
And 30 degrees. Anyone?
Oh.
Yeah, guys, most likely if you never seen this trick before, right? You go something like this. You use 1.5 equals to sine 30 over sine r, and you'll find r as a very small number. Maybe it's like 17 degrees or whatever it is. Most of you guys will do something like this. This is wrong, by the way. I want to highlight that whenever you see this sine I over sine r formula, this one here is always going to be the angle in the air. And this one here will always be the angle in the medium, guys. Okay, regardless of whatever the question may say. A lot of people they say that, hey, they say that this is the incident ray, right? Then this should be the incident angle, right? No, you should not. In reality, your calculation should be 1.5 is equals to sine I over sine 30, guys. Then with this calculation here, you'll be able to find your I, which is going to be bigger than 30 degrees, guys. Okay, boys and girls. I'm gonna end it here today, guys. If you have any questions, you can. Yes. C is the critical angle. Okay. Sorry. Removed from your syllabus. He's just still teaching you that. Latent heat of fusion and then vaporization no longer in physics. Yes. Yeah, for critical angle, only one formula. Mhm. Easy. Okay, guys, anyone else got any questions? Good. I expect everyone to score very well today. Okay, guys, that'll be it for today.